Hello and welcome to Lowering Costs, Raising Expectations in Calculus using Alta and OpenStax. Thanks for joining us today. I'm John Britch, a marketing nerd at Knewton. You've entered this web conference muted to preserve audio quality, but please use the questions field to type us your questions, or if you click raise your hand, we can unmute you if you'd like. We're very flexible here. So thanks for joining us. So we have 45 minutes, and it's 35 minutes and then 10 minutes for questions and answers. And so these are the three questions we hope to answer. What is Alta? How does Alta help students? And how can Alta be used with OpenStax? This session is being recorded, and we'll be sending you a link after the session. So joining us to answer these questions are Sharon North, Professor of Mathematics at St. Louis Community College, and Dr. Becky Moening, who's a content person at Knewton, a Knewton nerd. Jumping right in, Sharon, can you tell us about yourself and your institution?
Yeah, sure. Hey, everyone. I'm Sharon North. I'm a for St. Louis City and County region. I've been teaching there for 21 years, and I teach mostly gateway mathematics, so Calculus 1, but also statistics, pre-calculus, quantitative reasoning, trig, also the new co-rec classes that we're offering. On that last slide, I want to mention my students. I've got a group of calculus students in this photo working on graphing some functions and finding the Riemann sum using left hand, right hand, and midpoint sums. And they were all working so hard that day, I thought I'd snap a picture of them. Okay, and then in terms of where I teach and who we serve, St. Louis Community College is a 4-campus system. As I said, we serve students throughout the St. Louis City and County region, and each of our campuses has a center for excellence. And our center of excellence is our engineering and manufacturing programs. So we see quite a few engineering technology and engineering transfer students. Most of my students end up transferring to either Missouri S&T, the engineering school at Rolla, Missouri, which is one of the finest public engineering schools in the country, or the joint engineering program through the University of Missouri St. Louis and Washington University here in St. Louis. And, you know, I'd say that for all of these students, a really solid foundation in calculus is critical to their success moving forward. So we are always looking for ways to improve, you know, like really improve our calculus course as well as our math program.
Super. So first question, Sharon, why did you choose Alta?
Yeah, well, in 2015, I decided to make the move to open educational resources. I was teaching a pre-calc class and noticed that none of my pre-calculus students had a textbook. And so after class, I walked over to the bookstore and, you know, our pre-calc text with its tutorial software was priced over $200. Our students just struggle financially, so many of them could simply not afford to purchase a text. And I'm a really strong advocate for equity in higher ed and felt all my students should have access to materials for the class. So that's when I decided to move to open educational resources. And my colleagues at our Forest Park campus had already been using open ed resources. So I decided it was time for me to investigate this. But after using OpenStax for a semester or two, I really wanted to find an inexpensive but high quality courseware to accompany the OpenStax free text. And so in looking at that, really Alta was the only option that was adaptive and really could target my students' individual areas of weakness and help guide them toward mastery. And so, one thing I hadn't even planned on in using Alta were the analytics. And now I'm using the analytics to help inform my teaching. And we'll be taking a look at that in a little bit here in our discussion. Yeah, so just a little bit more information about OpenStax or Open Educational Resources. These are free materials in that a student can have access to the PDF version of the text for free online. Some students still choose to purchase a book, and those books are really just sold at the price of copying the text, so they're very inexpensive, about $44. But then again, I don't think this semester in Calc I have any students who have purchased. Occasionally I do. But then technology companies that partner with OpenStax to bring over content and really provide that courseware option to students.
Super. Thank you. So, and Sharon will be interjecting throughout, but joining us for a section at the end where she's going to talk about exactly how she uses it. But before we get there, we thought it would be useful to sort of define terms, because there are a number of different homework systems, and some of them claim many of them claim adaptivity. There are learning management systems. So we thought we'd spend a few minutes just talking about what exactly is Alta and actually looking under the hood. And so Becky Moening is here to help us do that. And could you first tell us a little about yourself?
Of course, of course. I've spent about 10 years at Ivy Tech Community College in Northern Indiana as a department chair in math faculty, teaching co-recs, college algebra, quantitative reasoning, you name it, I probably taught it. I also facilitated the Dana Center for 2 years on co-requisites and math pathways. I've worked in the publishing industry as a content developer on the side, and now I am a content developer full-time for Knewton as of November. I'm also in charge of all things co-rec here. So I'm glad to be with you today to talk about calculus. So what is Alta? Basically, we are an adaptive software, as John and Sharon have mentioned, and we want you to be able to teach your class however you want, and with confidence that all of your students are with you in terms of the level at which you are teaching. So we meet your students where they are, and through our adaptive platform, we help them get them where they need to be. So even though we are a technology company, we focus on learning. So we want to empower you, the instructor, through our technology. Thank you. Knewton has been around for about 10 years as an adaptive learning engine. And only a little over a year ago, we decided to launch Alta, which is our product, so that we can partner with faculty for courseware, as Sharon mentioned. And we wanted to make sure that this was not only affordable, but high quality. So recently, Johns Hopkins has done a study on some data from a past semester to make sure that we were offering that high quality material that we wanted to. And the study confirms that all students, regardless of ability, can learn with Alta. And that is really our goal, right? We want to make sure that not just the advanced students can learn, but those struggling students can learn also. We'll talk more about that study in just a little bit. So how do we come up with all of our content? Well, we get this from multiple sources. We, as Sharon mentioned, partner with OpenStax and other OER providers to kind of get a base content. We partner with universities and professors all over the country for videos, content, to help us write some questions. And then Knewton has a content team, which I'm a part of. We vet all of that OpenStax material. We write our questions. We author new instruction. We fill in the gaps wherever we need to. And OpenStax is not our only partner. We also partner with Desmos, and we are going to talk about Desmos everywhere and how that's in our product to help students have a more engaging graphing experience in terms of online content. This is kind of a pictorial example here of our learning paths. So we call this a knowledge graph, and our courses are all connected. So if you are teaching a calculus class, you may still be bringing in material from pre-calculus, or trig. If your students are struggling with a particular concept, it can be pulled in wherever your students need that particular piece. You can just see how everything is connected through these edges so that each student gets their own personalized adaptive learning journey. And now I believe we're going to go to a live demo. So if we could share my screen. We're going to talk about 3 different little mini demos today. And the first one, as I mentioned, we talked about Desmos everywhere. We are constantly rolling out new Desmos products. So not only, we're mainly focusing in calculus and college algebra right now, but they will be over all of our math courses shortly. So this is an example of Desmos within instruction. So a student covering maybe tangent lines or the slope of a tangent line is going to see this graph in their instruction piece. And you can see you can kind of move this dot along, right? Which no big deal right now. That's just the function f of x. If I move this dot to the tangent line, now as I move that dot, students can actually see the tangent line and how that line moves depending on the point where it is tangent, right? So then we move it down again. Now you can see that where that point, now we can actually find the slope of our tangent line. So students can see, hey, look, the slope is getting bigger the steeper the line. And, you know, close to 0 because it's a horizontal line. Now we're getting, now it's a negative slope. So they can visually see what happens as that point moves along the original function. And then my favorite part of this, as we move this dot, you can also see it's graphing the parabola, also known as the derivative of the original function. So students now have a visual of how all of these pieces are connected. And they can play with this as much as they want, right? Because this is part of their instruction. And this would then lead to another question with Desmos and understanding how these pieces are related. So I think that could be really, really powerful within instruction. Another way that we are incorporating Desmos could be Riemann sums. So you'll notice on this, we have ourselves a nice, beautiful function here. And on the right-hand side, we can decide how many rectangles we're using. We're using 5, 6, 7, 3, but you can decide that. And then students have the ability, okay, do they really understand what a left point Riemann sum is? Maybe, maybe not, right? So they put their rectangles in, and then it shows them the area. So this is a left endpoint. There are questions with right endpoints, right? It's all different types. But they have the ability to really show that they understand, one, how it works, how it's connected. They can see the difference between the area if they use less or more rectangles. So now we have all of these different pieces of the graph and how to use it, and all engaging, right? This is not a multiple choice question where they just guess which one works. No, they actually have to fill in the graph. So it's very, very exciting. All right, so then let's go to a demo of what the course would look like. So if a student was in the course, this is what their assignment would look like. You can see down here at the bottom where this white rectangle is the learning objectives. So in this particular demo, we only have 1 learning objective. Sometimes there's 2, 3, 4. It just depends on the assignment. So the title of the assignment is up top. The learning objectives are at the bottom. This is the first spot where students can view instruction. So if they have no idea how this topic is just confusing to them, they can start with instruction. Or, like most students, they just want to jump right into the homework. This empty bar at the top here underneath the title is our progress bar. As students get problems correct, the progress bar fills in. So this particular problem, we're going to graph the tangent line at the point, or at the point 2, -2. So they have the point 2, -2. My job is to graph the tangent line. So, okay, boop, there's a tangent line. You can see at the bottom, again, I have more instruction. So if I get to this problem and say, wow, I don't know what to do, I can go to instruction with no penalty, or I can guess and hit submit. Now, this is a free response question. So students have 2 tries. So, okay, I'm sorry, that's the correct line, submit. I got it wrong. So you can see after I get it wrong twice, they show me both incorrect answers. And then, hey, here's the correct graph. And this is the step-by-step. Remember, use the chain rule. And it shows step-by-step how this problem is done. So if a student, missed it, they can then go through maybe their work on their paper, compare it to this and say, there's my mistake. Our data shows students who miss problems do spend time reading the answer explanation because we have all of that data coming back to our in-house brain, as I like to call it. So I'm moving on to the next question. And you can see this next question is not a graph. This is just find the equation of the tangent line. So of course the answer is 3. And I hit submit. It's wrong. I got 2 tries, but I'm still wrong. And again, step-by-step answer explanation. So we go through, again, we have a formula equation question. And I don't know what I'm doing because obviously I haven't read the instruction. I've missed 3 problems in a row. The system now says, whoa, you obviously are struggling somewhere. Let's give you some instruction. Most learning objectives have instruction in 2 ways. One way, as you see here, is a video. So we could watch this couple-minute video. It will then be followed by a follow-up assessment question. So the assessment follows the video so that they're related. So they're either going to be a video or it could be written instruction, kind of like you would see in a textbook. And it just depends, it's kind of a flip of a coin of what comes up. As students continue to miss problems, instruction will come up again. And after a certain number, they will say, okay, you need extra help. About only 14% of our students are remediated for needing extra help at different spots. But John, if we could go back to the static slides, please.
Sure.
So this goal topic, as I like to say, is use implicit differentiation for the equation of a tangent line. So that was the goal topic, and every student will start on the goal topic. As I keep missing problems, I then, in this case, would be remediated to use implicit differentiation and the product rule, because maybe that's where I'm struggling. So as students miss problems and they're remediated to a topic, again, Knewton is gathering all of this data. So if I start answering these questions right, and then I go on to answer the other questions correctly in the goal topic, that's showing that, yes, this helps remediate. And so students will continue to see this type of a question when they need help. Let's go to the next slide, please. However, when I get to that prereq topic, if I continue to struggle, I'm going to be given more instruction. So you can see this would be an example of some text instruction. It's just, and I copy and pasted here, but a basic explanation, again, with step-by-step how to do this problem. Next slide, please. And then again, by another problem. So that's kind of the basic flow. But we had to go to the static slides because students have to miss a lot of problems before they are prompted with prereq material. So it's not you miss one and you're kicked out. No, they have to really show that they are struggling to be remediated. And a lot of our students that we've seen, because we have that step-by-step feedback and that forced instruction, they're getting enough knowledge there that they don't ever really make it to these prereq material. They understand and they learn the topic beforehand. So one more thing I just want to point out, you see, John, can you go back one real quick? I'm sorry. At the bottom of this slide, you see this more instruction button next to that feedback. So again, this is where students can get the more instruction, and then this feedback button. At any point in time, if you find that you think a problem is either incorrect or it's worded poorly, or there's any feedback you would like to give, you as a faculty member and students can use that feedback button that comes directly to either the content team, client services. It comes to whomever that particular feedback goes to. If there's an incorrect piece in the system, we have it corrected usually within 24 to 48 hours because we don't want anybody else to have to deal with that incorrect piece. If it's just general feedback like, I really don't like that wording, That might take a little longer. We might have to weigh pros and cons of changing wording. But if there are mistakes, we definitely take care of those very quickly. Okay, John, I'm ready for the next slide. Thank you. So I've talked a lot about our content development team, and then I talked a lot about data. Well, we also have an in-house data science team that is amazing. This team takes all of the data compiled from the students that are using this product, and they're constantly looking at what do those numbers show us. You know, if a bunch of students are missing a particular question, you know, that comes to the content team of, hey, 30% of students are missing this. Why? Right? Is it because it's worded poorly? Is it wrong? Is it in the wrong spot? What's wrong with this? So we are currently looking at data to drive our revisions. And again, if there's a problem, we respond in real time. We get that message fixed so that no other students have that same problem. And then let's talk about success. So we at using Alta like to talk about mastery, right? Not every student is going to have 10 problems. We want students to work to mastery, and this is all students. So when you think about all students using Alta, 87% of the time they achieve mastery. That's overall all students. But then think about your classroom. You have students who just come in and they're just fabulous, right? We call them, you know, advanced. They know what's going on. They learn things quickly. They take zero time to understand. They're just advanced. And then you have those students who come in and you're like, wow, have you ever seen a calculator? Because they just struggle at everything. So we've got this wide range of student ability in our classrooms. But even those students who struggle, who we think, wow, 82% of them achieve mastery through Alta. So Alta is not just for those advanced students, it's for all students, and all students can achieve mastery using this product.
Yeah, I'll just add,
oh, go ahead. Sorry.
Interject about my calc class and my students. So we just had our first exam today, and this is where I kind of do an Alta check-in to see how they're all doing, see their mastery level. I assign their first grades in Blackboard for Alta work. And one thing that they love is that they can continue to work until they get that 100% mastery. So even if it's a student who came to me with, you know, gaps in their understanding, they can keep working at it until they get to that 100%. And that's just been really motivating for these students. So I'd share that little piece with you on that.
Absolutely. And the Johns Hopkins study actually also confirmed that. Struggling students usually take a little bit longer, but they achieve mastery at nearly the same rate as advanced students, which makes sense. If they're struggling, they're probably going to take a longer time. Yes. Somebody else going to say something?
Okay, I found this on the web for I'm.
What? Okay.
Who invited Siri?
Yeah, it's nice. Okay, so this slide is actually one of my favorites just because I like visuals. So this little graph here on the horizontal axis, we have the assignment learning objectives mastered at Knewton. So the left-hand line segment dots there, the endpoints, are mastering at less than or equal to 25%. So if we have students mastering at less than or equal to 25%, our struggling students, the purple dot, will generally score about a 40% on the related quiz, which makes sense, right? If they're not mastering, they don't understand the material, they're not going to perform well on the test or the quiz. Advanced students, on the other hand, may score roughly like maybe a 70 on the quiz without mastering. Now, if you look at the right-hand dots, this is where the equalizer comes in. If students, struggling, average, or students are mastering at 75% or better, they're scoring almost the same on quizzes, right? Our struggling students are about 78%, and our advanced students are maybe about 85%. But that's pretty darn close when you think about where they're coming in, advanced versus struggling. So when you talk about mastering in Knewton, it's leading to higher scores later, which means they're obtaining or they're retaining their information that they're learning. Next slide, please. This is another one that just shows how mastery can help later. So struggling students, when they come in, are probably going to take more time to master the content. That makes sense. But as time goes, you can see the purple bar being struggling students, they need 40% less questions to achieve mastery later. So as they work through the semester, they will actually take less time to complete their assignments and reach mastery, which makes sense, right? We think about math being, it's a building course. You need the stuff at the beginning to do well at the end. And if students are mastering the material at the beginning, they're retaining that information, which is allowing them to complete subsequent assignments at a quicker pace. And this isn't just for struggling students. You can see the average and advanced students also take less time to finish, to master assignments as they work through the course.
Okay, so now thank you, Becky. Now we are going to talk about how Sharon actually uses Alta and OpenStax in her course.
Okay, yeah, so one thing that has been really nice about using this open educational resources is that I can reach out to my students before the semester begins, tell them what book we'll be using and share with them the link to the free text, and also share my Alta course code so students can get started in the class actually before we begin. And the problem we always had with that before is that, students are waiting for financial aid funds and they're not able to purchase their book, so that's no longer an issue. One thing that has been nice about using Alta is that they will offer a 2-week complimentary code. So again, if my students are waiting for, the $44 actually to purchase Alta, they can get started with that 2-week code, and all of that work then will be saved once they actually pay for their code. So last semester, something that was really great, I was teaching 5 classes with Alta, and 100% of my students were able to purchase. So that really was a vast improvement from just a handful of students being able to purchase to 100% of my students. So the way that I use Alta, I use it as a homework system, but I also use it as flipped instructions. So I actually expect students to get in there and start working with the content. I have a calculus course that is partially inverted, meaning we're going to do work in class that's more conceptual work, or the tougher application problems, because my students really need to master these application problems to be successful when they transfer on to their engineering courses and engineering programs. My grading is, based on, I have 4 exams throughout the semester. I, still give pencil and paper exams in class. These conceptual and activities that we do in class, I call those labs. So every time that we do a lab, which is almost every day, a student will turn that in the next class session, and I grade those for 5 points each. And then the homework on Alta, which is really a huge undertaking because a 5 credit hour calc class has quite a few learning objectives. That counts for 200 points of the total. And then, of course, I have a comprehensive final that all students have to take that totals 150 points. So that is my grading system that I'm using. Yeah, I mean, since I mentioned this idea of flipped instruction, I'll just say a few things about it. What I've kind of moved out of the class that I'm asking students to do is more of the skill and drill work in Alta. And like I said, we're spending class time on the tougher conceptual and application-based work. With a flipped classroom, the teacher really chooses the method of delivery. What's beautiful about Alta is that The videos are already there, embedded in the content, as well as those slices of the OpenStax text that Becky was showing when it's, when she clicked on more instruction. And so, really each class now includes some active learning component. And what that really does for my students is that, they're more engaged. They're really more satisfied with the class because they're getting to ask questions and they're getting to talk to other students about their work. And really, it leads to, nationwide, if you look at some data from the National Science Foundation, we actually just got a 3-year NSF grant to flip STEM content. Students are more likely to stay in class and do, perform better.
And just to interject, later this month on February 20th, Sharon will be doing a session specifically on flipping the calculus classroom. So as I send my link with a recording to this session, I'll also send information about signing up for that topic-specific session.
Great. Thanks, John, for adding that. Yeah, so how I create a course, basically the way that the content in Alta is aligned is around the idea of learning objectives, which is good for us because our district has certain learning objectives that each of our campuses has to ensure that we, cover with students. And so I can then take out our district curriculum documents and really then create my course around these required topics. And so then each of the learning objectives has kind of sub-objectives that you can either turn off or on, depending on if you need to cover that. And yeah, probably most of those sub-objectives are turned on in my class. Occasionally there's something that I won't need to cover and I can switch that objective off. And so, yeah, here are some of the analytics from one of my classes. And here we can see that, for example, if I'm kind of doing a check-in and taking attendance and my students are working in group, I can really, see who is achieving mastery, meaning getting, 100% of that content down, who is not. And I can easily then click on this green kind of segment here to show the 14 students who have reached the mastery, 4 that are on their way, and then the 6 that are, having a tough time with it. I can also see if my students are active, meaning they've used the system in the past 7 days, or inactive. And I'll mention to my students, hey, I see 8 of you are inactive, and kind of the 8, look down, and I'm like, don't look down. I know exactly who you are. And so I think that they appreciate that I care enough to continue to reach out. I also have an option to email, either the inactive students and say, hey, we've got a quiz coming up. Let's get back into it. Or the students, who have reached the mastery and kind of say, hey, nice work. I noticed that you're, above 90% mastery. So keep up the good work. This will pay off. And then next, this is a copy of the midterm report that is sent to me by Knewton. And again, it gives me some data on, really how long it took students who were unfamiliar, for example, with the content, or more familiar average students to get through these assignments and learning objectives. So that's really nice for me. I want to make sure that this is all doable and the amount of time my students have to work on this. And then my morning emails. Okay, so when I look in my email in the morning, I'll have a message from Knewton telling me how many struggling students I have on each of these different topics. It kind of gives me an idea of what I need to hit in class again. I can go ahead and click into the email and see exactly who's struggling, get back into the system and see which students need help. And then I can make sure to, visit their groups, talk to them a little bit more in class. So these analytics actually inform what I do each day in class. Yeah, here again, you can just see some summaries on, how many of my students are reaching mastery. In terms of the test scores, I do occasionally give quizzes in Alta. If we've run out of time in class, I'll create a quiz and give that to my students. I've also started doing diagnostics at the beginning of the semester, and I have my students take that diagnostic in Alta as well. That kind of gives them an idea of where they are in terms of, all the prereq content that they need to master to be successful in this class. And of course, the support. Becky mentioned this, that, they always get back to me right away. I do let them know if I, see, for example, a typo or if something is misleading about a certain question. And so, yeah, they are really great about getting right back to me. And, if I have to, again, report any kind of issues, I generally hear back right away.
Super. Thank you. Thank you, Sharon. So we're going to open it up to your questions. If you have any questions, please enter them in the question bar, type them in the question bar, and we have a few minutes to answer them. Here's a question. Can instructors add their own free response questions to Alta?
So I can address this. I can add my own free response questions into the quizzes or the exams. Because I'm adding, though, the problem, it won't be part of the adaptive system. And so, Becky, what could you add to that? Is what I said accurate?
It is, yeah. And the only reason you cannot add to the adaptive system is because I talked about those edges of how everything is connected, including the prereq material. So if you would add things in, that would kind of wreck our graph. And in order for us to continue to gather data and analyze that data, we have to keep that graph intact. So yes, the only way you can add questions is those separate quizzes and tests. Yep.
Yeah, so like in my diagnostic, I added a question on the difference quotient, for example. And, it was pretty easy to use. I hadn't gone through a tutorial. I was able to figure it out and get the, different versions of responses added.
Okay, another question. Does Alta integrate with Canvas?
Yes, it integrates with all LMS systems. So Canvas, Moodle, Desire to Learn, Blackboard, all of them. Yes, seamlessly.
Another question about tests. Can instructors print out tests from Alta?
Yeah, I can address that. So when I'm making up an exam, or in my case, the quizzes, but in the past with my quantitative reasoning and stats reasonings, I would design practice tests for my co-rec class. I can print out a copy, and then I can switch that over then to having my students take that in class.
Another question, Sharon, how do you like the OpenStax text?
I actually enjoy the text. I think that they are, well written, and I think they have some really good, questions. Problem type. So I know that some of my colleagues are not quite as fond as I am. I think I'm a little bit more accepting because I want to see all of my students have this, free access. And I put together so many materials for my classes. I think my students really just kind of use those labs and materials that I create to help supplement the text. But yeah, I think it's the OpenStax books are really amazing in that we've, been able to get that material to all students.
Yeah, and if I can piggyback on that, Sharon used the word supplements, and we have here at Knewton also PowerPoints and supplemental worksheets to go with every course to kind of help you with in your course, however you would like to utilize those.
Okay, last call for questions. So if you have any questions, please type them in. In the meantime, I'm just going to, we've mentioned it, but let me clarify on price. For the summer courses, summer semester, Alta will be $44. However, for the fall, the price will be $39.95 per semester. So Alta's will be $39.95 per semester come the fall, and the OpenStax text, as Sharon said, is completely free. And I don't see any more questions coming in. So we're gonna sort of end just showing you all the different courses that we publish Alta for. And like, as I said before, I will follow up with an email with a link to a recording of the session. If there's a question that strikes you after we adjourn, please just hit reply to that email and ask away. And we can also set you up with a more in-depth demo or a sandbox course. So be on the lookout for that email. And thank you, Sharon, and thank you, Becky, and thank you to our attendees for spending some time with us.
Yeah,
Thanks, everybody.
thank you, everyone. I certainly appreciate your time and your dedication to your students. So thanks a lot for joining us.
Thank you. Take care. Bye-bye.
Bye, everyone.